Okay, so they start you off pretty easy, pretty straightforward kind of questions. I put the formulas there at the top. Sometimes people will ask me for them, but did they come through better on yours? The formulas? They look like it. Yeah, they're better? They're not very good up there. Okay, so let's have a look here at number 7. Kitty O'Neill, a female dragster, reached a speed of 628 kilometers per hour from rest in 3.72 seconds, and that's actually true story. 412 miles per hour. If that's more your speed. You get what, Shade? It's kind of quiet today. How far did she travel in that time? So what do we know? We know her final velocity. Did you miss one? Sorry. Okay, so we got the final velocity. We have from rest. And we have the time. How far did she travel in that time? So we're looking for displacement, d value. Which formula has all that in it? Looks like a two-step question to me. I got d equals vit plus half at squared, but I don't have the acceleration. And I've got vs squared equals vi squared plus 2ad, but I don't have acceleration. So I think I need to find acceleration. Vf equals vi plus at. Final velocity. Oh, now, do we need to, should I convert 628 kilometers per hour? I should? How come? Like, or is it just, because time is in seconds, you're right. Okay, so I know you guys can't do that, but I'm going to do that. So 628 divided by 3.6. I know I have these written down somewhere. I'm not going to get a calculator. You should have got 174.4. 174.4 meters per second, and then we're going to throw that in over here. 174.4, the initial velocity is 0. Solve for acceleration, and our time was 3.72. So really, we're just dividing by 3.72, and you should get an acceleration of 46.9 meters per second squared. That's pretty quick acceleration. And now to solve for displacement, I'm going to recommend Vf squared equals Vi squared plus 2ad. Final velocity is that 174.4 value. Make sure you square it. Initial velocity is 0. Acceleration 46.9, and we're going to solve for the d value. So that's going to be 174.4 squared, and we're going to divide by, now you can do this two ways if you want. If you want to go 2 times 46.9 in your calculator and then write that number down, but you should also be able to, and it would be a good idea to learn a little bit about how your calculator works. Put a bracket there and go 2 times 46.9 in another bracket. And I would actually encourage you to try that on your calculator right now to get a handle on that, because you're going to get the answer and you can see if it's right. And I get 324.3 meters. Make sure you close that bracket before you hit equals on your calculator. Just try that while I do attendance. Okay, relatively straightforward? Yeah? Okay. Did you guys got that okay on your calculator? You made it work? Yeah? Okay, here we have a Ferrari moving at 20 kilometers an hour and accelerates to 230 in 7.5 seconds. As it does so, it covers an unknown distance. Find the distance covered. This seems to me to be virtually the same question, doesn't it? What's different about it?
It's a Ferrari.
And there's an initial velocity. Other than it's a different kind of car. That's right. So really, it's going to be exactly the same thing. We're going to have to go 20 divided by 3.6, 5.6. And the final velocity is 230 divided by 3.6, 63.9. VF equals VI plus AT. 63.9 is equal to 5.6 plus acceleration multiplied by the time of 7.5. Now, I'm going to put this all in one step. I'm wondering if you can follow the math here. I'm going to write A equals, and maybe some of you can try this on your own here. What would be the steps? A is equal to what? I'm going to start with 63.9. What do I have to get rid of first over here? The 5.6. I'm going to subtract 5.6 from both sides, and then I'm going to divide by 7.5. And I'm hoping that that's mostly okay for many of you. 7.77. Just making space for myself here. And then this one here. How would I write this? See if I can stretch you a bit more. What's the first thing to get rid of? The 5.6 squared, right? So 63.9 squared minus 5.6 squared. And then I'm going to have to divide by that 2 times 7.77, right? Put that in brackets. Are we good with that? Please ask if that's stretching your solving abilities. And you should get 260.8. Yeah? Now in the textbook, I'm not sure how they want you to find the acceleration in example number 9, which is crazy because you have to find that first. So someone in the textbook business screwed up. Is that the next question? No, it's not. Do you have this one? Should we watch this first? I wonder what it is. We're solving for acceleration. We've got the displacement. We've got the time. Do we have the initial velocity? Is it 0, Martin, even though the car is moving? It's in the same what? It's in the same frame of reference, right? So it's at rest with respect to the person that's sitting in front of it. You're absolutely right. Good job. VI is indeed 0, even though the car is actually moving, right? I mean, it could be at rest. It could just be sitting there, right? And someone runs into the front of your car. So D equals VIT plus 1/2 AT squared. So that displacement is 0.4. The initial velocity is 0. Do I need to write 0 times the 0.03, the time? The initial velocity is 0, so we're just going to write 0. And we're solving for A. I guess I should have it. A times T squared 0.03 squared. What's A going to be equal to here? I'm really pushing the math here. We got to get rid of the half. 1/2 a is really a divided by 2, right? So to get rid of divide by 2, I multiply. So it's going to be 2 times the 0.4. And then the 0.03 squared is times a. So to get rid of it, I'm going to have to divide. Okay? Do you need brackets at the bottom there when you square? Your calculator should do the squaring first, but you'll have to remember to hit equals. Just go ahead and try that. And I'll tell you, should the number be a big number? Yeah, right? Did you get that? Yes, that's fast. And it had better be, right? Yeah, and that is 100% true, right? You saw the video. It's about 30 milliseconds, 35 milliseconds, 40 centimeters about how far it goes. So that is the actual acceleration of an airbag. You want to try one? No. A question. They're clearly violating copyright law there by calling this person Jane Bond. Although I presume that name actually exists. Why don't you give that one a try? There's a little twist on this one here at the end. Jane Bond runs down the sidewalk accelerating uniformly at a rate of 0.2, so that's our acceleration. Initial velocity is 3, that's our initial velocity. How long will it take Jane to travel a distance of 12 meters? That's our displacement. We are solving for time. So which one has d, v, I, a, and t in it? D equals VIT plus 1/2 AT squared. She needs to run 12 meters. Her initial velocity is 3 t plus 1/2, and your acceleration here is 0.2 t squared. Uh-oh. What have we got? Trouble? We got ourselves a quadratic here, don't we? How are we going to solve this? We're going to put everything on one side, set it equal to 0. We're going to have half of 0.2, which would be 0.1 t squared, plus 3t minus 12. And how are we going to solve that? Quadratic formula. Remember how much fun that is? And the only reason I do this is to remind you about this. B squared minus 4ac all over 2a. Everyone seen the quadratic formula before? So, what is the b value? The b value is the one that goes with the x, which is in this case, the t, right? So that's going to be plus 3, so it's going to be minus 3, and it's crucial you get the signs right. Plus or minus square root. B squared is going to be 3 squared minus 4. A is the t squared, or x squared, which is 0.1. And the c is this one here, which is minus 12. And again, it's crucial you get your signs right. All over 2 times a, which in this case is 0.1. So I'm going to have minus 3 plus or minus square root. 3 squared is 9. So 4 times 0.1 times negative 12 is going to be negative 4.8, but it's subtract that, so it's going to be plus 4.8 all over 2 times 0.1 or 0.2. What happens if the number under here is a negative? You give up. You can't do it. There is no solution. Not in the real sense, exactly. Not in the physics sense. Okay? Does anyone remember what the name of that number underneath the square root is called? You're close, Josh. It starts with a D. the discriminant. Anybody ever heard that before? The discriminant. Okay, so that's going to be minus 3 plus or minus, so 9 plus 4.8, you're going to take the square root of that. So minus 3 plus or minus 3.7 all over 0.2. Now, do you have to do what does the plus or minus mean? Well, it means you got to do both, right? So it's minus 3 plus 3.7 all over 0.2, and it's also minus 3 minus 3.7 all over 0.2. But this one's going to give you negative 6.7 over 0.2, and I don't know what that is, but it's a negative number, and negative time doesn't exist, right? So that answer doesn't happen. When you're doing a quadratic, right, you've got this type of thing, and you're solving for those zeros, but in the physics sense, this portion of time doesn't exist, does it? Okay, so you can ignore that. So our answer here is minus 3 plus 3.7, so that's going to be 0.7 all over 0.2, which is only 3.5 seconds. This number over here, by the way, is actually minus 33.5 seconds, but it has no value, no bearing in sort of the real world here. Okay, does that make sense? So just a quick review there on quadratic formula. Okay, so I'm going to give you the rest of the time. Is the next question Fred and Barney? Okay, Fred and Barney is a good solid 20 minutes. So I'm going to leave that one. I'm going to give you the rest of this period, and I'm going to give you, I'm going to suggest that you do some stuff at home as well, and we'll do Fred and Barney tomorrow. But before any of that, have you guys seen this in the news? This is kind of physics related. If you're looking for more problems to work on, they are on page 64, numbers 1 to 3. And page 73, and don't freak out on me here, numbers 33 all the way to 66. But you don't have to do them all. Just pick ones, like they're just extra ones to practice. In that group, you can leave out 50, 54, 55, and oddly enough, number 60. So those are just some extra ones in the textbook you can do.